Michaela finds all the possible ways to draw a path in a 5x5 diamond-shaped grid. Each path starts at the bottom of the grid and ends at the top, always moving 1 unit northeast or northwest. She computes the area of the region between each path and the right side of the grid. 2 examples are shown in the figures below. What is the sum of the areas determined by all possible paths? So the first thing that we'll do is first find the number of paths from the bottom of the grid to the top. Now it turns out this is actually a pretty well-known counting problem. You can see that this is a standard path counting problem by rotating the grid by 45 degrees. So the number of paths, every path must go northwest 5 times and northeast 5 times. So the number of paths will be 10 choose 5, which is 10 times 9 times 8 times 7 times 6 over 5 factorial. This is equal to 252. Now for each path, we want to find the area of the region to the right and add them up. But instead of finding the area for each path, we're going to make a clever observation. That observation is the fact that for every path from the bottom to the top, there is one equivalent path that we can pair this off with, such that the sum of the areas is 25. So let's see an example to kind of illustrate this idea. Using the path on the left with area 11, let's say I take this path right here in red. So this is the path obtained by reflecting the black path over the vertical diagonal. You see that for the red path, there are going to be 14 squares that are to the right of the red path, which I'll use an X to denote. Similarly, for the path on the right with area of 13, there are going to be 12 squares in the corresponding red path, as shown here. So one way to see this fact is also to look at the white squares from the black path, which are not shaded. Those are going to be a reflected version of the red squares that I've used an X to denote. So that's another way you can verify that the sum of the areas by these 2 paths will always be 25 for each pair. So this means that out of the 252 paths, we can pair them off into 126 pairs, and the sum of the areas in each pair will be 25 square units. So this means that the sum of the areas is going to equal 126 times 25, which is 3150. The answer will be B.